All right, let's dig in. Today, we're getting into a topic that is quite literally right under our feet, but it's one we almost never think about: soil. And trust me, this isn't just about dirt. We're about to pull back the curtain on a secret world, a super complex system that has a story to tell about the land itself. So, what is that story? I mean, what can the ground beneath you actually reveal about the climate, the life, and the geology of your little spot on the planet, stretching back thousands of years? Well, that's the big question we're tackling today, and we're going to learn exactly how to read that story. To read any story, you first have to understand the language it's written in, right? For soil, that language is its blueprint, what scientists call the soil profile. This is our key, our decoder ring for figuring it all out. So what exactly is a soil profile? Okay, imagine taking a giant slice out of the earth, kind of like a huge piece of layer cake. That vertical slice is the soil profile. It shows you all the different layers, right from the grass on top all the way down to the solid rock deep below. And each of these layers, these horizons, is like a different chapter in the land's biography. And you might be asking, why bother reading this biography? Well, because this blueprint tells us some incredibly practical stuff. It reveals a soil's fertility, for growing food. It tells us how well it holds water, and even if it's stable enough to build a house on. It's the essential first step for pretty much everything from farming to construction. All right, let's start the journey. We're going to travel down through the soil profile, exploring each of those distinct layers, those horizons, one by one, starting from the living surface and going all the way down to the solid bedrock. So here's our roadmap. A fully developed soil profile can have up to 6 main layers. They're labeled O, A, E, B, C, and R. And it's actually pretty easy to remember. It goes from the organic stuff at the top all the way down to the rock at the bottom. Now, let's see what makes each one special. We start at the tippy top with the O horizon. The best way to think about this is as the soil's living skin. It's made up of all the dead leaves, twigs, and other organic stuff that's breaking down into this dark, rich material called humus. You'll mostly find this layer in places like forests, where it acts like a protective blanket and is just buzzing with microscopic life. Now, just below the surface, we hit 2 really critical layers. First is the A horizon, or topsoil. This is where all the action happens. It's dark, it's fertile, and it's packed with roots and organisms. Then, right below that, you have the B horizon, the subsoil. It's usually denser and has a lighter reddish color. It basically acts like a storage unit, catching and accumulating all the minerals like clay and iron that wash down from the layers above it. Okay, digging deeper, we find our last 3 horizons. Sometimes right below the topsoil, you'll find an E horizon. The E is for eluviation, which is just a fancy way of saying washed out. It's a pale layer because water has stripped most of its minerals away. Further down is the C horizon, which is basically weathered, broken up chunks of rock. It's the raw parent material for the soil above. And finally, we hit bottom, the R horizon, solid, unweathered bedrock, the foundation of the whole system. So these layers don't just magically appear out of nowhere. They're actually the result of a very slow, very specific recipe, cooked over thousands of years with just a few key ingredients and processes. This whole system is so dynamic. It starts with weathering, which is just rock being broken down. At the same time, at the surface, you have humification, which is dead plants and things turning into that vital organic matter. And then you get this really cool push and pull. Eluviation is water washing minerals out of the upper layers, while eluviation is that process of those minerals building up in the lower layers. It's a constant cycle. So what controls this recipe? Well, it really boils down to 5 key factors. The biggest one is the parent material. What kind of rock did this all start from? Next up is climate, because rain and heat control how fast everything happens. Then you have organisms, all the bacteria, fungi, plants, and animals doing their thing. The relief, or the slope of the land, matters too, because it affects erosion. And the final secret ingredient? Time. Good soil isn't made overnight. We're talking hundreds, even thousands of years. We've journeyed all the way down to bedrock, and we've learned the recipe. But let's bring it all back to the surface. Why does understanding a soil profile actually matter in the real world? What's the practical side of all this? Well, it's pretty clear it matters a lot. If you're a farmer, the soil profile tells you everything: what crops to plant, how much water they'll need. If you're an engineer, you have to know the profile to understand if the ground is stable enough to build on. For environmental scientists, it's absolutely key to managing ecosystems and fighting erosion. Seriously, from farming to city planning, reading the soil is essential. When you boil it all down, it really comes back to this:
A soil profile is so much more than just layers of dirt. It truly is a biography of the land. It's a detailed record of everything that's happened in that one spot: the climate, the geology, the life, the death, all of it, written down over an immense timescale.
So, the next time you walk outside, I hope you'll think about that for a second. The ground beneath your feet isn't just a surface to walk on. It's a library of natural history. It's telling a story that's thousands of years in the making. So it makes you wonder, right? What story is your soil telling?